Alright, here we are in 1-2, multiplying fractions. Now, this is a bit of a basic review. You learned this, theoretically, you should have learned this in the 3rd and 4th grade. However, I know a lot of students struggle with this, so let's kind of review this and make it fairly simple. So, what is a fraction? Well, we see 2/5 here. This is a typical fraction, and it's something that is less than 1. Like you can have 2 slices out of a pizza that only has 5 slices. You've eaten 2/5 of that pizza. What if we have something called an improper fraction, 8/3? Well, notice here the numerator is larger than the denominator. Well, this means it's greater than 1. So this would be something like, let's say you had $2.50. You can't say you have $2 or $3. You have somewhere in between 2 and 3. We need a fraction to justify how much you have. Now, what's the rule for multiplying fractions? It's going to be top times top over bottom, and I'll just abbreviate bottom as BOT, times the bottom. Okay, so on the top we have 2 times 8, which will of course be 16, over on the bottom times the bottom, 5 times 3, which is in fact 15. Now, the next question you ask after you multiply these is, can I reduce it? And all you're saying is, hey, do these have any common factors? So for example, 16 can be divided by 1, 2, 4, 8, and 16. And we never worry about 1, because every single number will always have the factor of 1. 15 can be divided by 3, 5, and 15. Well, you'll notice there are no factors in common, so we say that that is in fact reduced. It is the simplest that we can make that fraction. At any time that I finish these examples, I would encourage you to pause and finish writing down, but we're going to move on to the next example. Okay, here we are on example 2, and let's throw in a negative. Let's do -3/8 times 4/6. Now, as I multiply these, when we say top times top, you can always put this negative with either the top or the bottom, but I would prefer you always put the negative with the top to make things easier. So -3 times 4 will in fact be -12, over 8 times 6, which would be 48. Now, 48 is a pretty large number, but I hope you would know that 2 and 8 are both even numbers. Anytime we have an even number, we can always at least divide by 2. So, -12 divided by 2 will equal -6. We'll just bring this on down here. And 48 divided by 2 will actually give us 24. Now, you should probably feel pretty comfortable with both 6 and 24. In fact, you should know that 6 and 24 can both be divided by 6. So I can just divide this top by 6, I can divide this bottom by 6, and -6 divided by 6 would equal -1, and 24 divided by 6 would be 4. And this is the most reduced version of this fraction. Alright, let's move on to our example 3. Okay, example 3. Let's do something that kind of throws students for a loop. What if I did 9 times 3/7? And sometimes students get confused because you look at 9 and think, well, wait a second, it's not a fraction. Do I multiply 9 by the top and bottom? Well, remember, any whole number can always be written as that number over 1. So 9 times 3 on the top will give us 27, and on the bottom 1 times 7 will be 7. And of course that is as reduced as it can get. Now, in terms of reducing, I actually want to show you a pretty cool trick which will make your life very, very simple. So let's use some large numbers here. Let's say 20/12 times 18/15. You might be thinking, hey, Mr. Hastings, these are some very large numbers. I don't think I can do this in my head. And I would argue, in fact, the opposite. You definitely can. So let's look at this 20. I look at the 20, and I'm going to look at the 20 and the 15, because I want you to know that as long as you're multiplying, you can take the top of one number and put it in relationship with the bottom of another number, and it's fine so long as they're being multiplied. This does not work with adding, only multiplication. But if I were to ask you, what factor do 20 and 15 have in common? Well, I would hope you would say they both have 5. And so we can divide both the top and bottom here, both of these numbers, by 5. Now the way you would do this, you would say, well, I know that 20 and 15 can both be divided by 5. 20 divided by 5, you cross it out, 20 divided by 5 is 4. And 15 divided by 5 is 3. Now I want you to look at the 18 and the 12, and pardon this siren, the downsides of living next to a fire station. This 18 and this 12, what is the largest number that you know of that both 18 and 12 can both be divided by? And yeah, if you said 6, you are absolutely correct. We can divide both the top and the bottom by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. And we could multiply these here, or you could even see something even more interesting. On the right side, we have 3 over 3, and what's 3 divided by 3? Well, that is the same as saying 1. We have essentially changed this into 4 over 2 times 1, which is just 4 over 2. And remember, a fraction bar means to divide, so what is 4 divided by 2? Well, that's just going to be 2. So there's no real right or wrong way for you to tackle multiplying by fractions and reducing. You can reduce them before you multiply, or you can reduce them after you multiply, or you can reduce them some sort of combination in between. Now let's look at our fifth example here. Okay, let's throw in some negatives. Let's say I said negative 3 over, how about 11, times 7 over 4. In fact, let's make that negative as well. So we have a negative times negative. Okay, well, let's take what we just talked about. Does 3 share any factors in common with 11 or 4? The answer is no. Can 7 share any factors in common with 11 or 4? And the answer is also no. And since we know that they don't share any factors in common before we multiply them, that means you can multiply them and understand that at the very end, this thing cannot reduce. In fact, this will make your life so much simpler. So we do top times top. A negative times a negative is a positive. 3 times 7 is 21 over 11 times 4, which is 44. And we know by looking at the components, this cannot be reduced any further. I want to do one final one. Let's do example 6 here. And just for practice, let's use large numbers again. Let's say 15 over, how about 10, times 12 over 8. Now in this case, the reason I chose this one is because 15 does not share any common factors with 8. But 15 does share common factors with 10. So we can actually reduce this fraction before we touch anything else. We know that 15 and 10 can both be divided by 5. And 15 divided by 5 will of course give us 3 over, and 10 divided by 5 will give us 2 times. And when I look at 12 and 8, I ask myself, what is the largest number that both 12 and 8 can be divided by? And we should know that they can both be divided by 4. Okay? And 12 divided by 4 will of course give us 3, and 8 divided by 4 will of course give us 2. And check this out. 15 over 10 and 12 over 8 were in fact the exact same value. They are in fact being multiplied by themselves. Even though they look differently, they have the same exact value. Now from here, we can simply say 3 times 3 will be 9, and on the bottom 2 times 2 will in fact be 4. And just for like a higher level extension, is there a different way that you could write 3 over 2 times 3 over 2? Well, think back to our last lesson when we talked about squares. 3 over 2 times itself is 3 over 2 squared. So this is yet another way that you could kind of write something that's the exact same. Alright, I hope this helps, and I'll see you guys in our next section.